What's going on, guys? Mr. Jones coming at you once again. Today we're going to do task 5.5, all for one, one for all. So have the Desmos activity open, guys. If your Desmos is not open, make sure you get it open before you move on to the next part of the video. In other words, pause me. All right. Here we go. So this one has sliders. Basically what the sliders are is just a way for you to change the number in the equation. So here's the original equation in standard form. That's standard form right there. AX plus BY equals C. A, B, and C are all values that you're going to plug numbers into, right? So you can read this to yourself, but basically it's just talking about Carlos and Clarita have 6 minutes twice a day to feed and clean cat litter boxes. So it takes a total of 12 minutes for cat feeding and cleaning. For dogs, they have a total of 20 minutes per day to walk the dogs and feed the dogs. They have a total of 8 hours each day for these activities. Okay, they have a total of 8 hours. So what you're supposed to do is realize that in the equation, X represents cats and Y represents dogs. So since A is next to X right here, A is the number of minutes it takes, number of minutes to feed cats, okay? Number of minutes to feed each cat. And B is the number of minutes it takes to walk each dog, okay? C is the total number of minutes that they have available at their disposal. So move these sliders around and pick the appropriate value that A, B, and C should be, and this should be make the equation for you. So go ahead and pause and do that. All right, so hopefully you realize that A is the total number of minutes they have for cats, so you're going to put that at the 12, right? That's the 12 right here. B is the number of minutes they have available for dogs, so that's going to be 20, right? And the total number of minutes they have altogether is 8 hours worth of minutes. So that's where kids might have gotten confused. 60 minutes per hour, 60 times 8 is 480. So 480 should have been your equation there. All right, so over here on the right, you'll notice that I put the equation that we came up with. I plugged in my A, B, and C value in for the equation. And this equation is for cleaning the litter boxes and walking the dogs, right? All right, go to the next slide. The next slide, you're going to do the exact same thing, but it's for a different scenario. Now this scenario is talking about brushing and petting each cat, and it's talking about bathing and playing with each dog, right? So it gives you a number of minutes. You see 16 minutes for cats and 20 minutes for dogs. So go ahead and do the sliders, and go ahead and pause to do that. All right, so since you chose A as still brushing and petting cats, that was 16. And B was 20 minutes for dogs again. And guess what? They still have they have another 8 hours, so it's 480 once again. Now, hopefully you realize that this equation now was 16x plus 20y equals 480. And this one is for what? Brushing and bathing. Brushing the cats, bathing the dogs, that kind of stuff. And here's the equation, right? But do they actually have to equal 8 hours? Like if they're able to work fast, would they be able to get out of there in 7 hours possibly? Sure. So that's where the inequalities come in, right? They don't actually have to equal 480. In fact, as long as they could be less than, okay, whatever we get over here, once you plug in the number of cats and dogs you have, all it has to be is less than or equal to 480, right? Less than or equal to 480. And same thing over here. We're always able to be less than the time. We just can't be greater than the time, right? So now we truly have the equations written down with the inequalities. Remember, as you read the equation, you know which way to put the sign because whatever side of the sign comes first. That's the less than side, that's the greater than side. So 16x plus 20y needs to be less than, so point it towards that, right? All right, next slide. Now what you're going to do, it says, let's make the graphs from all the previous two slides to include the inequality. Sketch the area of the graph that includes all possible solutions. In other words, where are you going to shade this line now? Okay, so this one is the first graph. That's the very first graph, this one, right? Crosses at the 24. So that's this graph again. Where does this equation say to shade this? Go ahead and grab your little shade tool, I guess the pencil, and color in either above the line or below the line. Which one do you guys think? Pause and do it. All right, hopefully since you read it, 12x plus 20y is less than, you realize that you're going to be really shading everything under here, right? That means that any value under here should be true. And one thing I do want to point out before I forget is really you're only shading stuff from here all in here, but you're not going below the x-axis and you're not going to the left of the y-axis because remember, x is cats, okay? X is cats. Can you have negative cats? Can you have negative dogs? If y is dogs, if you have a negative y value, does that mean you have negative dogs? So negative y value is everything down here, right? Negative x value is everything over here. So you can't have anything like that. It has to only be in this first quadrant. All right, now you're going to make the graphs. This is the second one. So go ahead and shade this one, guys. Where would you shade this one? Hopefully it's the second one. Looks pretty much the same to me. Oh, it looks different. The x-intercept's different. All right. So where are you going to shade this one? Hopefully you guys are already just shading away, right? You got all down here all shaded because it has to be less than. It can't be greater than 8 hours. Less than, right? And then you get to the next slide, and hopefully it looks like this. And then the second one looks like this, which we did. Those how ours looked, but just not as beautiful, right? Okay. So then you're going to go here and say, what if we put the two graphs together? Okay, what would that look like if both of them were together? So now here's the two lines together. It's saying go ahead and shade. What would you shade if this was an inequality, if both of these were together? Go ahead and give it a shot and see where you would shade. All right, so really you're just going to shade everything underneath, but not below the blue line. It has to just be the lowest point possible, right? So that's kind of where I would shade. But let's go to the next slide because look at this. So this dark orange area is the actual answer that fits both equations at the same time. That means any point in here, any combination of cats and dogs that falls within this dark orange area would work. You'd have enough time to do it. This light orange way up here, besides the fact that it's on the left of the y-axis, it wouldn't work because it doesn't fall below the blue line. And then this one right here, all this blue area means that it works for that blue graph, but it won't work for the orange one. So you have to make sure that they both work, and that's what we're calling super shaded, the one that you're shading twice, right? All right, now it's game time. That was just kind of a little review to get you guys rolling. So, Carlos and Clarita have found a way to represent combinations of cats and dogs that satisfy each of their individual pet sitter constraints, but they realize that they need to find combinations that satisfy all of the constraints simultaneously. So there's actually 4 constraints. Remember, we have the cat pins and dog runs, and we have the money. Now we have time to clean and walk and time to brush and bathe. We have all this different stuff going on. Okay. As a refresher, here's the 2 inequalities so far that we had before this. So we still have these 2 right here, okay? But now we also have 32x plus 80y has to be less than or equal to 1280. This is the one for dollars that we had available. That's how much money, 22 bucks that it costs for cats, 80 bucks for dogs. Okay, this one was space. It cost 6 square feet for cat pins and 24 square feet for dog pins, and that has to be under 360 square feet. Okay, so make sure you write all of these together because we're going to put all of these together on one graph today and talk about which amount of cats and dogs will fit all 4 at the same time. I bet you can't wait. Okay, so now you're going to graph them. So I'm going to let you guys go ahead and do this. It says graph both startup cost and space. Okay, so this one is cost, this one is space. Go ahead and put both of these on the graph. I'm going to show you how to do one of them. You do the other one. So you can type in 32x and then plus is on your keyboard. By the way, it's all down here on this keyboard if you need. But I like to type it with the regular keyboard. So 32 plus 80y. And then you're going to hit the less than sign, which is right the same button as the comma, and then the equal button. And once you hit the equal button, it'll turn that inequality into less than or equal to. Okay? So hit the less than symbol followed by the equal symbol, just like it's showing here. Don't put the and then put in 1280. And then you're going to have your graph there. Okay? Now you make sure you graph the next one and see how it looks. Remember, you're going to be looking for the super shaded, right? So graph them both together. Hopefully your graph looks like this. Don't stress if the colors of the graph are not the same. Mr. Norman's colorblind and can't tell the difference anyway. So, don't worry about it. You just know this color is different than this is different than this, and that's what you're worried about is the super shaded region, right? All right, using the equation from slide 11 and your graph from slide 12, state 5 combinations of cats and dogs that would satisfy both of the constraints. Okay, represented by the system of inequalities. Write your responses in the ordered pair form. So I'm going to help you. Here we go. Slide 11, slide 12. So we got to go back to slide 11, and it says, okay, we're going to look at the equation, and we're going to look at these two graphs, by the way. And by now, hopefully, I guess I could type this in. Okay, by now, let's see. Is that right? Oh, no, I put in the wrong equation. My bad. All right, there we go. Let's make this one not red. That's no fun. We'll make it orange, and we'll make this one blue. Nice, nice. All right, so now we have our two graphs from slide 11, and it says use those graphs to give me 5 points that work for both equations at the same time. Remember, those are the points in the super shaded region, so you could pick any point in the super shaded region. So I'm going to pick, I don't know, 10. We'll pick one that's high. We're going to pick 1010 right here. 1010 is definitely a point that falls within this super shaded region. Okay, so go ahead and write this like this, 10, comma, 10. Okay, and you're going to do that for the next point. You can choose any 5 points that fit within the super shaded. Okay, then you're going to do this again, and you're going to state 5 combinations that would only satisfy one of the constraints. So go back to the graph here. You could actually just use this one, right? You could use this one. Where do you think you'd get the points from that only fit one, right? Which one would only fit one line but not the other? Hint, you could choose a blue point or an orange point, right? And you're going to choose 5 of those and put those here. Okay, so now you're going to have the inequalities. You're going to put those inequalities, hopefully you wrote them down, in here. Okay, you typed them in here in these last 2 slides. Now you're going to come over and you're going to put them over here. So let's do one. Right here in this first section, I'm going to put 10, replace the x, replace the y, and now I have the point 10, 10. You can see it's green, and it is showing up in my super shaded region. So hopefully you realize that all 5 of these first points should be in the super shaded region, and all 5 of the next points should definitely not be. They should be either in the blue section or the little orange section. Don't pick points that are outside this area because those don't actually make sense, right? All right, referring to slide 16, what's the color of the shaded area of the graph? I'll let you guys read this. I'm pretty sure I don't have to explain this. All right, and now it says, reference back to slide 11 again. Let's see if you can make a standard form inequality for both feeding time and pampering time. Guess what? I made it for you. It's on the screen right now. So hopefully you realize we already went over that, right? That was for pampering time and feeding time, yes. All right, hopefully you ended up with this. Holy moly, we sure did, because that's what's on our screen. And now we have these 4. So now it has these 4 lines all at the same time. See if you can figure out where you would shade, guys. Where would you shade to make all of the inequalities be true at the exact same time? You can always pause, by the way. I go fast, you just pause. and then unpause. All right, check it out. This is what it should look like. This is the ultimate shaded region that's below all the lines at the same time, right? So it doesn't matter how many lines you have. If we pick a cat and dog combination within this shaded region, that will work with our cleaning walk-in schedule, our brushing and bathing schedule, our cost, and our space. We've just started a business, and we could actually still pick 10 cats and 10 dogs. In fact, we might want to pick a couple more because then we can get closer to maximum profit. All right, guys, go ahead and answer these questions. What do you notice about the graph on slide 20? What do you wonder about the graph on slide 20? That's this one. Okay. And then using the graph on slide 21, the one we just looked at, state 5 combinations that would satisfy all constraints. So what does it mean to satisfy all constraints? That means it's going to be in the super shaded region, right? So put your 5 points in there, guys. And then you're going to put the points right here, and hopefully they pop up in the super shaded region. Hopefully you realize it's all this area right here below all the lines at the same time. Put in your 5 points here. And then, once again, I want you to pick points that are not matching, that only fit some constraints, but not all. So they could be part of 1, 2, or 3, but not all. Put those 5 there, put those 5 there. And then bada bing, bada boom, you're done. Task complete. So hope you guys have a great day. Hopefully this was helpful. If you guys have questions, please let me know. I would love to help you. Mr. Norman would love to help you. Mr. Hernandez would love to help you. We would love to see you come to office hours. Okay? If you made it to the end of this video, pat yourself on the back and have an excellent day. Bye.